Audio Jungle.
Welcome to part 3, guys, and in this part we will be converting our data into our training data. So let's see what it is. Now we have done 1, we have done 2, we are now in this part 3. So we'll be doing A, B, and C. We'll be doing these 3 things. So let's see what these are. Okay, first of all, now as you know, we have these kind of lemmatized words in our words dictionary, and we have our classes that each of our pattern falls into one of these classes. We have classes that looks like this. So now what we are doing is, now if there is a pattern that says hey you, now the uh, that is stored in an array like this. So it's hey comma you. The whole sentence hey you is divided into hey comma you. Now what we are doing now is we are converting this hey comma you into this bag. So this bag is mapped to words. If you see here, hey is the first word. So the first index is 1 here, and then how becomes 0 because there is no how here, and then we have you, and then in our uh, third item is 1 because this u maps to this u. So this bag is actually words in our 1 or 0 form, and all the other words are 0. Only the words that are in our pattern are 1. So hey becomes 1, how becomes 0, u becomes 1 because u is in our pattern, hospital becomes 0, near becomes 0, and all the rest are 0 because definitely they are not in our pattern. And then we come to our output. So our output becomes which class our pattern falls into. So our hey you falls into greeting. So the first item is 1. Now this output is a kind of like a mapping of these classes with the class that the pattern falls into being 1 and the rest of the classes being 0. So as you can see here, this output is 1 0 0 0 because our pattern is greeting. So the first index is 1 and the rest are 0. The rest are 0. Now we are doing this because this is how we are going to train our model. All right. So this becomes the input, that is the first word and the second word are in the and the third word are in the pattern from all these set of words, and the output for this input, this bag, we have this output. That is, in this output, this is only a greeting and the rest are 0. So we have our x and we have our y, and that's how we will define our training data. So as you can see here, as we have discussed, there is x and y. X is the input, y is the output. So if the input is this bag, then the output is this. What we are trying to say is, if the input is hey you, then the output is greeting, right? So if we can recognize the classes of class of data that our sentence falls into, then we can generate an output from the possible list of outputs for that class. All right, so we are creating a training data that contains x and y. The x is the bag and y is the output, and so we'll do this for all of our patterns, like hey you, how are you where are you going, find me a hospital. For all those out patterns, we'll create a bag and an output, and this x and y will be added to our training data. All right, so let's get going. Okay, so first of all, let's just create a training array that is an empty array. What is wrong with my spelling? training. Training, this is an empty array at the moment. And let's create an output array that will be empty. So let's call it output empty. And initially we are just setting all of this to 0 because we'll change that later. So what we are doing here is we are creating an array that contains all zeros and has the size of our classes. All right, so this is like 0 comma 0 comma 0 comma 0 0 comma 0, this kind of stuff, and the number of zeros is the length of items in our classes array. So this becomes our output array. All right, now if we go ahead, we go up, and we know that we have all our patterns with its corresponding class in these documents. So what do? We loop through each of the doc in this documents. Let me scroll down a little, and then we initialize a bag that is initially empty, and then we get the pattern words from our doc. So this is the 0th index contains the pattern words. Now if we scroll ahead, our doc is like, okay, this is not commented here, but essentially our we are appending something like this. First it contains hey, you, and then it is a greeting. So this is what we have in our documents. So as you can see here, the first index hey comma you is our pattern, and the second index is it's actually 0th and first index. The 0th index is hey you, and in 1 we have the class. So that's what we are getting from here. Now in doc 0 is our pattern words, right? Now we are lemmatizing our pattern words so that we can compare it with our bag, with our words, because the words dictionary contains all the lemmatized words. So let's lemmatize it. For word in pattern words. So now this is a very neat way to loop through the pattern words and convert that into an array. If you have any problems with this, let me know in the comments and I'll be happy to clear your doubts. Alright, so now we have lemmatized our pattern words. Okay, let's just print what pattern words are so it's easier for you to understand what we are doing here. Okay, now we have our pattern words ready. Now let's create the bag. So for each word in our words dictionary, words list that contains lemmatized words, what we are doing is we are doing bag.append 1 if w is in pattern words, right? Else we are just appending 0. All right, so as we discussed, if the word is in our pattern words, we will have 1 in its place in the bag. If it does not, if that word is not in our pattern, then we append 0. All right, so let's come out of the loop and print this too, so you can understand what we are doing. Print current bag dot format bag. All right, this is also current pattern. All right, now what we are left to do is, now we have our bag. Now we need to create our output ready. All right, so for that, let's say output row equals to list output empty. So in our output row also we are saving output list, but what we'll do is in our output row we need to find the index of our class, right? So hey you is greeting. So in our output row, in our classes list, which of the item is greeting? So how do we know that? We can just go classes dot index of, it's not actually of, index of doc 1. So what does our doc 1 contains? It contains, as you can see here, it contains the class. So we are finding out the index of our class from our classes list, and we are setting that to 1. All right, and now let's just print this to current output. Let's check this out. Output row. Okay, now we'll append this into training. what do we append into training? In our training, as you know, we always have x and y values, right? So what is the x value? X value is the bag. What is the y value? Y value is the output row. All right. Okay, so now let's run this so we can see what we have created, which words are there, and what is the bag for the pattern, and what is the output for the pattern for this pattern word. All right. So where we are, let's run this. What is the mistake? String attribute has no double MAT. Where am I? Where have I gone wrong? Okay. So as you can see here, we have our pattern words, we have our bag, and we have our class. So let's just go through. If the pattern word say is hit there, this is the bag. So we have all zeros, and here it is 1. So in this index, we must have high in our word dictionary, and then we go through here and we get to here, and this must be the there word in our word dictionary. So the bag becomes this, and so for this bag, what is the output? This is the output. In output, we have 1 in the second last index. So this index, we must have greeting. All right. So for this bag, this is the output. For this bag, this is the output. Now the pattern what says, how are you? So this is the bag, right? This is this one here and a one there and a one here, but it's still a greeting. So the output is the same as the first one. All right. So in the first few sentences like hi there, how are you, is anyone there, hey, hello, hola, hello, good day. So all these are greetings, right? So as you can notice, it's just in our output array we have one in the last, in the second to last index. So all these are greetings. All right. So let's move ahead now. Now we have understood what we are doing here in our bag, what we're doing with our output, what we're doing with our words. So let's just comment this for now. And we have our training data. So we did not print training. So let me just print training data also after this is complete. But it's going to be, it's kind of it'll be looking like garbage. So don't get mad. Let's just print it and see where we are. All right. So if you print the training array, as you can see, this is all bags and outputs, bags and outputs, bags, and this will look like a giant mess, but rest assured, this is not a mess. Okay, let's comment this. Now, one thing that we saw here was there's a pattern here, right? So the first few sentences all are greetings, right? So as you can see, the classes here, this is a greeting, this is a greeting, this output is also a greeting, this output is also a greeting. So all these are like sequenced. It's like in a pattern, right? The first it is greeting, and then we have bye, and then we have see you later, and then we have goodbye. So these are all, what are these? These are all, what classes are these? Goodbye or whatever the class name is. So all of these patterns are fall into those class, and similarly the next group of words or the next sentences are in a specific class. So what happens if we are providing this kind of training data is our model is generalized. It starts generalizing, like these words are the specific sentences into a specific output. So why is that happening is because we are providing it a sequence of data. Like, we are already providing a kind of pattern to our model. So what is a good idea is to shuffle our training input. All right. So in technical terms, what we'll be doing is we'll be overfitting the data. That is not what we want to do. All right. If you are a little confused, you as you understand more about this training and modeling, you'll be clear about it. But for now, what we need to do is, as far as possible, we do not try to provide a specific pattern of data so that our model does not learn the data. All right. So what we do is random dot shuffle, and we shuffle our training data. That's all. And now, once it is shuffled, we are converting this into a numpy array, because we'll be converting all these things into x and y. We'll be converting this into an x array and a y array. Right now, all our x and y are grouped into one array. We'll be converting that into two different arrays. With one will contain x and one will contain y. For that, this np array is very helpful. Np is actually numpy. All right. Now, what we do is we'll split it. Train x becomes training. No, first we need to convert this into a list. List training colon comma 0. Now you cannot do this with regular Python array. I'm doing this because now we have converted this training array into a numpy array. All right. Now our train x contains all the x values that are the bags, and the train y contains, what does it contain? It contains 1. Now you might be confused with this syntax here, so I suggest you read a little bit of slicing a Python array, sorry, numpy array. What we're doing here is we are just slicing our training array into all the x's are into train x, and all the y arrays are into y train y. All right, I just said x's. That's a bad joke. All right, so your x's are in train x and your y's are in train y. But let's just print this and see where we are. X train x and print y format train y. All right, let's see how far along are we. Now if we run this again, okay, random is not defined. So this random is not defined. Is this np defined? Okay, so we have not defined that numpy thing and random also. So we'll just import random, and we'll import numpy as np. All right, now we have these things too. Let's run this again. Okay, there is an issue here. Why is x and y not being printed? We shuffled our training data, converted this into a numpy array, and we're just splitting it. Is there an issue here? This is very stupid of me, guys. I wasted some time because of this now. We didn't have our parentheses, so where are we trying to display this? Very stupid. Anyway, let's go ahead and run this again. Okay, so now as you can see, we have our y's here. Y are a list of output classes, right? List of output bags, and then we have our all of these here, and these are our bags. And so as you can see here, now we don't have our classes in a specific pattern or a specific sequence. This is a different class, this is a different class, as you can see by the location of 1 here, or the index of 1, and this is a different one, this is a different one, we have one in second here. So that's why we did shuffle. All right, so now we have our training data ready, we have our x's ready, we have our y's ready. So let's go ahead and create our model. Finally we are here, and now we will be creating and saving our model. We have come very far, and I want to congratulate you guys to stick with me this far. And yeah, just take a few seconds to regroup, and I'm excited to get this started with you. And we'll be learning a lot of new things, new concept in this model. So take a few seconds, take a deep breath, and here we go. All right, now we have done this thing, and now we'll be creating a model. So first of all, let's just write model equals to sequential. Now I'll not be going to details of what these things are because it's too far outside the scope of this tutorial, but I will let you know what you need to know what these things are so that you can go ahead and create awesome things. Okay, so first of all, what is sequential? Now we said our model is sequential, right? So what is sequential? Now if we go here, we can see in a sequential model, layers are linearly arranged. Input is taken from previous layer and passed into the next layer. So this is what we are creating basically. This is one layer, this is another layer, and this is another layer, and this is the output layer. So what we are doing is we are taking input of one layer, and we are passing it we are generating output, and that output is passed on to another layer. So this is linear. So what is a sequential model is? It contains linear layers, and the layer takes inputs from one previous layer, and it gives it as the output to another layer. All right, so this is very simple. This is a sequential model. So this is what we'll be creating. Now we can create a functional model too. And what is a functional model? Why to use one another over another? And all those things require some mathematical digging in that we will not be doing now. So all right, now very easy. So we have created a sequential model. Right now we will be adding these layers. All right, so what we can do is we just go model dot add, and then we write a dense layer, and we need 128 units. The input shape is, once again guys, these are a lot of new things, so do not stress over this. We will go over what these are, so you'll understand what this is even if you don't understand how it is working and the deep mathematical things of these. So please bear with me, we will get through this. All right, so we have defined our input shape, and now we define, just a moment, the length of training, comma 0. Now I'm a little confused with this, so many braces here after 0. Okay, my bad, it's here, and then we have 1 after this. This is done. What am I doing? So input shape is the length, and then another comma for another parameter. The dense layer is done here. Once the dense layer is done, we need to define an activation function, and the activation function is relu. I'm sorry guys, I myself was confused, so why won't you be confused? So this is the whole thing, and now we add a layer here, right? So this is the dense layer, so this is like adding a layer here, right? This layer, and then we have an activation function, that is a relu activation function. Okay, so while defining a layer, we define how many units. So this whole thing is a layer, right? Now we'll be defining how many inputs are in the layer. 128. Now as you can see here, we have 3 4 5 6 inputs here. So in our layer we'll have 128 units. Now how many units are there and what activation function to use, these are all, you need to understand, you need to have an understanding of how this is working and all that stuff. So for now, let's just take this. Now when you want to study further about units and activation functions, you can understand, and it's basically hit and try, on how many units are working well. Okay, and yeah, this is pretty much it. So we have chosen 128 units, and the input shape is how we are providing our input, yeah, inputs, our axis, right? So this is the length of x, right? So we have our training data here, so we just calculate the length of the inputs here. So how many length of the zeroth, what do we have in the zeroth index? We have our bag, right? We have a bag, so the length of bag is given here as input shape because that's the number of inputs that we'll be giving. And we have our activation function that is set to relu. Now what is an activation function? So if we go here and see, activation function defines how the weighted sum of inputs is transformed into an output from a node or nodes in a layer of the network. So we have all these neurons, right? All these units, right? So we have 128 units here, if you see here. And now, by an activation function, we define when a neuron should work, when it should not work. That is when its output is used, when its output is not used. And that is defined a by an activation function. Now we have different kinds of activation functions, and in this one we have decided to choose ReLU. I I encourage you guys to learn more about activation functions, how they work, and all that stuff. But basically, what we need to know right now is we are defining which neuron will work, which neuron will be activated, which neuron will not be activated, and by this activation function. All right. Okay, now let's move ahead. So we have added one layer. Now we add a dropout function, a dropout layer. This is a probability of dropping out. Now, what is this dropout? Let me just explain it to you. Now, if we go here, we made sure that we did this random shuffle to ensure that uh, our model does not, start overfitting or learning the patterns of the data. So this is the similar reason we are adding this dropout here. So what this dropout does is it randomly drops drops a layer so that we are not dependent on that layer, or we do not overly rely on that layer, so we do not overfit our data. All right, then we add another model. Let's create a dense layer. Now let's reduce the number of neurons or units here, and let's have the activation function to ReLU again. This is another layer that we just added. Now let's add the dropout of the same 0.5, and finally we add an output layer. And how many outputs do we need to have, right? We need to have this classes function with the probability, the input. What is the probability of input being in an output class, right? So we will have the probability, so there will be probability for each class. So this will be the length of our classes, right? How many classes do we have? If we have 10 classes, we will have 10 output neurons that will give probability of the input for each input or each class. All right, so we will get the probability of an input being in each class if we do this. Now we define the activation function, and that is softmax. Now we use this softmax activation function in our output layer most of the time when we have probability for each of the output classes. All right, so when we need probability for each of the output class, what is the probability of an input being in an output class, then we use this activation softmax. All right, so we have our model ready. Now what do we need to do? We need to define we need to compile the model, and then we need to define an optimizer function. Again, this is a new concept, optimizer function. Now what is an optimizer function? Before coding, let's just slightly get an idea of what it actually is, even if we don't understand the deep, how it works and that stuff. So what is an activation function? All right, not activation function, optimizer function. Now optimizer function is basically an algorithm or method that is used to change the attributes of neural networks, such as weights, learning rate, to reduce losses. Basically, what we are trying to do, we are trying to reduce the loss and get high accuracy from our model, right? What output our model is generating, we need to ensure that there is less loss and high accuracy in that. So how do we achieve that? So this is what an optimizer function does. An optimizer function basically defines how we change weights, how we change biases of the units so that we get less loss. All right. So that is the function of an optimizer function. That is the use of an optimizer function. It defines how we increase the weight or how we decrease the weight, how we increase the bias or how we decrease the bias, how we change all that stuff so that we get a reduced loss. So that is what we are doing with our optimizer function. So here we'll be using uh, SGD optimizer function, that is stochastic gradient descent function. All right. So this function basically defines the thing we just had, that just thing we just discussed, how to reduce the loss. All right. Now we need to give a learning rate input to this. Again, we'll discuss all these variables in a moment, these parameters. Then we need to define a decay. This is the exponential function. And then we define a momentum. Please don't be overwhelmed with all these things. You just get an idea of what these things are. You don't need to understand all of these things fully right now. Okay, so let's see what these things are. Now, this is our activation function, right? We said the activation function defines how to change variables so that we reduce the loss. Now, this LR is, what do you think? This is not the loss rate, this is the learning rate, right? The learning rate is 0.01. So this defines, we have our weights and biases, right? We did not discuss that, but in our functions we have our weights and biases. So our learning rate defines by how much we need to increase our weights and biases or decrease our weights and biases. So if our weight is 1, what will be our next weight if our loss is very high? Will it be 3? Will it be 5? Will it be 6? So or will it be 1.2, 1.3? So that is defined by learning rate, right? So by how much we are increasing or decreasing our weights and biases. Now this decay is actually uh, reducing the learning rate. So as we go on, as the training continues, as we go on in our training and as we have done more and more of training, this decay actually reduces the learning rate, right? Because the learning rate needs to be high in the beginning because we don't know where we are going. But as we have learned a lot, our learning rate is reduced so that we change our trigger variables a little lesser than when we started. So that is defined by our decay. Now this momentum and this Nesterov, these are actually useful for the speed of the training, because if we have thousands and thousands or millions or even millions of data, then our training model can be very slow. This momentum actually speeds up the process. Okay, so basically you set this to true. If we set this Nesterov to true, it is better with momentum. So these two are related. All right, so now we have an idea of what learning rate is, what decay is, and what this momentum and Nesterov is. Nesterov is basically set to true in most cases because it helps speed up our process, our training process, and it works in conjunction with our momentum. All right, so now we have our activation function ready. We just compile our model with our activation function. Okay, all right, so we just go model dot compile, and the loss is, again, we'll go over this just in a bit. What is our optimizer? This is the SGD that we just created. And what is the metrics? We write accuracy here. All right, this is not compiling, this is compile, my bad. Okay, so now while compiling we give this loss parameter, optimizer parameter that we just discussed, and this metrics. Now this loss is how the loss of our output will be calculated. So we have outputs, but we have our actual outputs that we should have. So how that loss will be calculated? Now we have various methods of calculating the loss, right? If you had studied statistics, you know some of the methods that we can have to calculate loss, like mean, square, loss, all that stuff. But here, since we have categories of data, we will be using categorical cross interpret, right? So what this is we get the loss, right? Now, which our model will check the loss, how much loss do we have, and then by checking that loss, it will be applying the optimizer function. And finally, we have metrics. So this metrics is basically, we have set this to accuracy, so we'll be just checking the number of outputs that our model gets right by the number of model that our output gets wrong. All right. So now, finally, we have compiler model. So let's pass on our data, training data to our model. Okay. So let's say mfit equals to model dot fit. Now we pass on our training data. So we go convert this to a numpy array. So this is our input, that is train x, and then we have our output, that is train y, and then we have our epochs, that is how many times you want to train the model, how many times you want to run the training data through the model. So we have our training data, we want to we want our model to run over all those training data 200 times, and we have a batch size. So batch size defines after how many epochs do we change our model, or do we change the parameters of our model, right? The inputs. All right, now verbose, let's set this to 1. Now this verbose is nothing, it just displays the progress of our training process in the command line when we are training the model. If we set the verbose to 0, nothing will be displayed, so we will not know how far our training has been completed. So this verbose one actually shows something like a progress bar. All right, so now after this is done, we just save the model. Let's call it chatbot model.h5. This is the extension that you need to use, and this is our mfit. All right, and finally we print, yay, created my first model. Okay, so we have done these things. Now let's try and run it. So where is this chatbot? Okay, I'll go to my Python chatbot. Okay, now I'll okay, so let's compile our model. Let's run our file. Okay, why am I not seeing anything? Sequential is not defined, so okay, we need to import this. Now if we have not imported sequential, then I think we have not imported a lot of other things like dense and this stuff. So dense and SGD, we need to import dense, SGD, dropout, and sequential. All right, so let's go and import all those things. From keras.models, let's import sequential, and from keras.layers, we need to import dense, activation, and dropout. From keras.optimizer, what do we need to import? We need to import our optimizer function, that is SGD. All right, now let's run our Python file again, and I'm hoping we will be successful this time. Fingers crossed. Okay, we have an issue here. We saying cannot import activation because activation A is capital here. All right. Third time's the charm. Okay, again. It's not optimizer, it's optimizers. Like models, layers, optimizers. I was wrong. Third time's not the charm. Okay. What is wrong? Modded? Oh my god, I've done so many mistakes here. Where did I write modded? I am very sorry, guys. You must have been screaming, it's not TLL when you were watching the video. Okay, modif. What the hell? I feel so stupid. I'm not drunk and I'm not high. It's just an honest mistake. Okay, so as you can see, we had written verbose equals to 1, so that's why it's showing us this. Now, yay, created my first model. Finally, congratulations guys, we have come this far. I really want to congratulate you and I'm very happy for you. If you have any questions, let me know. And now we'll be moving on to our final part, creating the GUI.